Hello, everyone. This is kind of a review of your first exam, where I'll go through each of the different questions and provide an explanation for all the questions and the answers. So here's our first exam. Every single exam, you're going to have a front page or your very front page is going to look like this. Your back page is going to look like this. And most of the time, you're going to be able to take that exam with you. But here we go. Let's go ahead and get started. So question number one, a solid suspended in a liquid is most likely a hallmark of a pure substance, a homogeneous mixture, a bivalent mixture, and a heterogeneous mixture. Okay, so a solid, which is suspended in a liquid. Now, that solid being suspended in a liquid is pretty much a hallmark that these two things are not mixing perfectly with one another, in which case we're talking about a mixture, not a pure substance, and that mixture has multiple different components, therefore it is a heterogeneous mixture. Bivalent mixture, I just made that word up and threw that in there. It doesn't mean anything. Which element does not exist naturally as a combination of two atoms? So I added one word to this question. Obviously the copy that you see and that you will be given has this. I changed the question to be, which element does not exist naturally as a combination of two of the same atoms? So basically it's, is there such a thing as Cl2? Yes. Is there such a thing as B2? Let's come back to that. H2, yes. I2, yes. F2, yes. Are diatomic elements, H. Broncliffe is the mnemonic that I use. And so our correct answer does not exist as a combination of two of the same thing is going to be answer option B, which is element B, which is the element is boron. Number three, which type of matter is known to have a uniform composition is difficult to separate? Okay, so a uniform composition and is difficult to separate components. So uniform composition means that kind of every part of it is the exact same. And that is a completely perfect representation of a homogeneous mixture. So that homogeneous mixture, no matter where you are in that solution, it's going to look the exact same. And it will also therefore be difficult to separate the components. What separation technique uses different boiling points of substances? And that would be distillation. We talked a lot about separating different components of crude oil through distillation. Mass is an example of a chemical property, an extensive property, an intensive property, or an exogenous property. It's not a chemical property, it's a physical property. And then is it a intensive or extensive property? Now, I always think of an extensive property to illustrate the extent of that substance. So mass is an example of an extensive physical property. You can have more of something or less of something. Energy absorbed from surroundings, which changes matter from solid to liquid. So absorbing energy, an example of an endothermic process. An exothermic process, energy is released to the surroundings. So an endothermic process. A football kicker who hits the goalpost on every single kick, however, never puts the ball through the goalposts, is best considered accurate, precise, accurate and precise, lucky, neither precise nor accurate. I would say that since they hit the goalpost every single time, without fail, that is reproducibility. However, that's not hitting their objective. So that would be precise, but they're not going to be described as accurate. So A is out because they're not accurate. C is out. D is not really how we'd evaluate someone empirically. And so then our best answer is B. Okay. 236 milliliters is blank kiloliters. Your answer should have the correct number of significant figures. For this question, I'm going to switch over to the whiteboard. And I'll toggle back and forth, but it is 236.5 milliliters to kiloliters. Okay, so for these definitions, we need to go milliliters to liters, liters to kiloliters. 236.5 ml, there are 1,000 ml in 1 liter. There are 1,000 liters in 1 kiloliter. So we've got 236.5 divided by 1,000 divided by 1,000. We end up with 0.000. So we had 3 zeros and then 2,365. So we're looking at 2.365 times 10 to the, this is smaller than 1, so we're going to have a negative exponent. 1, 2, 3, 4 times 10 to the negative 4th kiloliters. Now let's switch back and confirm that that answer option is available. Times 10 to the negative 4th is what we're looking for. Okay, and yes, that is an option on there. Times 10 to the negative 4th. So B is the correct answer for that. Now, next up is you measure a table to be 97.64 centimeters and find out the actual table length is 94.44 centimeters. What is the percent error of this measurement? Select the best answer. So 97.64 and 94.44. So I'm going to go to a new table. We've got our test, which is 97.64 minus 94.44. That's a 4, I assure you. Divided by 94.44. And this ultimately gives us, go to my calculator, 97.64, it's 94.44. That gives us 3.2 divided by 94.44. So divided by 94.44. And we would come up with an answer that is 0.03388. And whenever you're dealing with a percent error, this gives us a fraction. So to convert it to a percentage, we just multiply by 100. And we end up 3.388. Now, one thing that is, okay, so we got 3.388. Now, if we look at our answer, we look at our question, we look at our answer, we've got 33%, 3.4%, 67%, 96.6%, and cannot be determined from the provided information. Okay, so our percent error, our best answer, ours was 3.388. In this case, and actually through our calculation, we get down to a total of 2 sig figs. So B is our best answer. I mean, independent of sig figs, that 3.4 is our best answer regardless. Next up is number 10. How many significant zeros are in the number 0.0004501? Now, these zeros right here are not significant because they're simply placeholders. And we would convert this number to scientific notation with 4.5 times 10 to the negative 4th. It's important to recognize that and remember that if a 0 is to the right of a decimal and it follows a non-zero digit, then it's significant. So we're actually looking at only 1 0 is significant. How many significant numbers are in the solution for 94.68 minus 32.1? And this is really getting to our rules of significant figure addition and subtraction. And if you look, whenever we're doing addition and subtraction, the lowest number of numbers beyond the decimal place is what's going to influence basically our answer. And so we have 94.68, so that's 2 digits beyond the decimal, and then 32.1, that's 1 digit beyond the decimal. So the correct answer is, or the The question asks us how many significant numbers or significant figures are in the solution. So we have one number beyond the decimal, so that's one sig fig. And then 94 minus 32 is going to be 62. So our correct answer is going to be something in the area of like, or for that, I'm going to go ahead and just write it out here on the page. 94.68 minus 32.1. Well, that's going to be, let's see, I'll go 3, 8. Oh, wait, I don't need to do that. I've forgotten how to do subtraction and all sorts of stuff. I'm sorry about that, everyone. Okay, so 94.68 minus 0.1 would be something like 0.58. So 64.58. Well, this number, we've got to get it to the right number of sig figs, which is influenced by that 32.1. So we're going to have one number beyond the decimal place. So we're looking at 64.6 as our answer. 64.6 is our answer for that subtraction. Now, the question is not asking about, well, what's the sum of this, but rather this question is asking us about the number of sig figs that are in the answer. And that would be 3. Okay, the next question. The solution for 94.68 times 32.1 has how many significant figures? Okay, this, we don't even have to do the math for it. We can just follow the rules for multiplication with and significant figures. Whichever number has the lower number of significant figures, that's going to influence our answer. That's going to dictate the precision of our answer. So we have 4 sig figs times a number with 3 sig figs. So our answer is going to be limited to 3 sig figs. Next up is convert 302.0000 to scientific notation. So I'm going to go to the whiteboard again for this. 302.0000. We got 4 zeros back there. 1, 2, 3, 4. To scientific notation. Now our conventions for scientific notation, we're going to have one digit to the left of the decimal and then all significant figures. Okay, well, there's no decimal place here. So not significant, not significant, not significant, not significant. So our last significant figure is this 2. So we would be writing 3.02, and then we're going to use a scientific notation and an exponent. So 302 times 10 to the, how many places did we move the decimal? 1, 2, 3, 4, 5, 6. So 3.02 times 10 to the 6th is our correct answer for this question. And this is why I do this, because I realize now that I don't have that answer. So I'm going to switch these to 6s. So the correct answer is C, 3.02 times 10 to the positive 6th. So here's that answer. We move the decimal 1, 2, 3, 4, 5, 6 spots. Okay, now going back to the exam, the correct answer for that was C, 3.02 times 10 to the negative 6th. And I'm going to highlight that. Now convert 29.5 miles per hour to centimeters per second. Okay, so, or meters per hour, I'm sorry about that. And I'm going to do this on the whiteboard. So I've got 29.5 meters in 1 hour. I am going meters per hour, centimeters per second. Okay, so I know that in 1 meter, there are 100 centimeters. And you know what? I'm done with that meters to centimeters conversion. Now all I need to do is go hours to seconds. 1 hour there are 60 minutes. And in 1 minute, there are 60 seconds. So I'm going to punch into my calculator whenever I get it open. 29.5 times 100 divided by, well, 60 times 60 is 3,600. I got 0.8194444444 repeating. Now my answer has 3 sig figs, so I'm going to write this 0.819 in scientific notation. So I'm going to write it as 8.19 times 10 to the negative first place. So I'll switch back over to my exam and make sure that I've got that as an answer option. 8.19 times 10 to the negative first. There it is, to the negative first, because it is less than the whole number of 1. All right, question number 15. How many 12-ounce Dr. Peppers can completely, that word is underlined, so it's significant, and it's worth noting, completely be poured into a 1 liter bottle? Now, to do this, I've given you the conversion from 1 ounce is 29, or I've given you the 1 ounce is equal to 29.6 milliliters. I'm going to make a new page on the whiteboard to show my work. So the question is basically, if I have, let's do it like this. 1 Dr. Pepper is 12 ounces. Now, I have a 1 liter bottle. And what I'm going to do is I'm going to ask myself, how many of those 12-ounce Dr. Peppers can I pour into there? So I want to start with 1 liter. A 1 liter bottle, 1 liter is 1,000 milliliters. My Dr. Pepper, well, I've got a conversion. And that conversion to go from milliliters to ounces is 29.6 milliliters is 1 ounce. Now, I've got 12 ounces and 1 DP, 1 Dr. Pepper. So this might be kind of a backwards way that you would think to do this, but you got to think about, what are we trying to fill up? What are we trying to, we have a singular Dr. Pepper, but we want to figure out how many of those Dr. Peppers are relevant to our project. So we're going to say 1,000, or 1 times 1,000 divided by 29.6 times 12. And what I'm going to do is I'm just going to write up 1,000, 29.6 times 12, 355.2. So 1,000 divided by 355.2 gives me 2.815. Okay, so now I've got 2.815. Let's look back at the question, because there's kind of a devil in the details. How many Dr. Peppers can completely be poured into a 1 liter bottle? So if our answer was 2.81, we can pour 2.81 Dr. Peppers. How many complete Dr. Peppers is that? 2. It's not 3, because we had 2.81. Is 0.8 Dr. Peppers a complete Dr. Pepper? It is not. So the correct answer for this is B. Next up is, how many protons, neutrons, and electrons are in gallium with a mass number of 70 and a charge of +3? So you've got your periodic table. And when you look at the periodic table and you see gallium on there, what you'll notice is gallium has an atomic number of 31, meaning it has 31 protons. Now, this isotope of gallium with 31 protons and a mass number of 70 means that it's going to have 31 protons and 39 neutrons. So those two numbers add up to 70, as we would expect and as we would hope for. Then the last question is, how many electrons does it have? And what we would expect is, since we have a positive charge on this thing, then we have a cation where we have more protons than electrons. 31 protons, so 38 or 31 positive charges and 28 negative charges. So those 28 negative charges will cancel out, in effect, 28 of those positive charges. So highlight C is our correct answer. Now, to consider some of the other ones, 70 protons, that's actually the atomic number for the element ytterbium. So that's actually at the bottom of the periodic table. If you have 31 protons, and actually for answer option A, 70 protons, 70 electrons, no charge. Answer option B, 31 protons, 39 electrons, a -8 charge. And then answer option D, again, that's an equal number of protons and electrons, so that will have a 0 charge whatsoever, or 0 charge overall. An atom of the element lithium has, okay, so lithium has an atomic number of 3, so it has 3 protons. Does it have 3 electrons? It doesn't. Generally, you can look at the average atomic mass, and it's going to be 6.94. So I'm going to go ahead and add a word, an average atom of lithium with an average atomic mass of 6.94. That's roughly 7. So that's going to be 4 neutrons as opposed to 3 neutrons. So your correct answer is C. Atoms with the same number of protons but different number of neutrons are commonly known as, okay, so we've got, oopsies. Okay, there we go. Atoms with the same number of protons but different number of neutrons are commonly known as, okay, so we've got 2 different atoms. They have the same number of protons, but they have different number of neutrons. Those would be known as isotopes. What is the correct formula, or what is the correct name for P2Cl4? Okay, so we got to find P on the periodic table. We'll see that it's on the far right-hand side. It is a nonmetal. Cl, far right-hand side. It is a nonmetal. 2 nonmetals coming together to form a compound. And if we have 2 nonmetals coming together, we're forming what is known as a covalent or molecular compound. Now, we have a total of 2 phosphorus, so we should expect di to be in there. And then we have 4 chlorines, and we should expect a tetra to be utilized. Okay, option A. That's not a good option because that Roman numeral 2 denotes you're talking about a transition metal. Answer option C, trichloride. That means you're talking about 1 phosphorus and 3 chlorides. Answer option D, you've got 4 chlorides, good. Diphosphate. Okay, so there's actually a couple things wrong with this. The convention is to name the atom that's first listed, name that one. So we've got this answer option backwards. In addition to that, that OUS suffix implies we're talking about an acid and a specific acid. So we're not talking about an acid here. And then answer option E, phosphate chlorinate. That's just throwing some, picking from some different rules and coming up with something that's a little bit wonky. So the best answer for this is answer option B. Which statement is untrue about nonmetals? Okay, so we're looking for something that is not true about nonmetals. So we are looking for, we've got answer option B, cannot conduct electricity well. That is true of nonmetals. Cannot conduct heat well. That is true of nonmetals. Not brittle. Well, nonmetals are very brittle. And actually, let me You know what? I was going through that question. I decided to change it because the wording was awkward and there's no point to have a question that has very awkward wording, let alone a question that I write and I think it's awkward. Okay, so I changed it to which statement is true about nonmetals? So nonmetals are highly malleable. That's a true statement about metals. Conduct electricity well, answer option B, and conduct heat well, answer option C. Those are both true of metals. Nonmetals, on the other hand, well, nonmetals are very brittle. So answer option D, not brittle, that's your best option. Nope, just a second. Okay, which is true. Just going to drop not there. Non-metals are very brittle. So answer option D. I was running into the problem of like 6 different a handful of different negatives. I had a double negative in there, and that's never good. Okay. Question 21, which I'm going to go ahead and, oh, I don't need that. Okay, question number 21. Question number 21 reads, argon has 3 major isotopes, 36, 38, and 40. And those isotopes, those 3 isotopes have the following masses and abundances. Okay, so we've got 36, which has a mass of 35.97 and an abundance of 0.337. 37.96, which has an abundance of 0.063%, and 39.96, which has an abundance of 99.600%. So based on this information, what is the average atomic mass? Okay, to answer this question, we've got 38.95, 39.95, 39.35, and 38.35. Now, judging by our abundances, 99% is that 39.96. So I'd be willing to say that we're looking to eliminate answer options A and D. We don't want to necessarily rely on, well, what's the kind of quick and dirty answer, or what's the quickest answer. But, you know, sometimes if you're pressed for time, especially with one of these last questions, you might want to take an educated guess. So we have 35.97 times 0.337. Put that in parentheses. Plus 37.96 times, that'll be 0.063 plus 39.96 times 0.996. Okay, this is the important part, you know, dealing with these small quantities. Well, those are fractions, not percentages. So that was one thing that I ran into a problem on. That 0.966 is 99.6 converted to 0.996. All right, 35.97 times 0.337 equals 12.12. I don't think that's right. Yep. I just said the mistake that I made. Okay. So this 0.337, that's a percentage. So that is 0.0037. This 0.063 is 0.00063. Okay. So come on, eraser. 35.97 times 0.00337, which is 0.1212189 plus 37.96 times point. There are 3 zeros. 0.02391 plus 39.96 times 0.996 is 39.80016. So 39.80016 plus 0.02391 plus 0.1212189 gives us 39.945, which, based on the answer options, the best answer is, so we got 39.945. Let's go ahead and look at our answer options. 39.95. That resembles what's on the periodic table, so you could have saved yourself a little bit of time there, but that periodic table might be a little bit different, or it might not have that number on there. Spoiler alert, for this specific question on your exam, you will not have that number. Okay, so B, 39.95 is the correct answer. 22, what is the name of the ionic compound MgCO3? Okay, Mg is magnesium, so we can cancel out answer options A and C. Now, CO3, that's one of our polyatomic ions that you're expected to know, and that is carbonate. There we go. What is the name of HI? Okay, this is an acid, and this acid is hydroiodic acid. What is the formula for the compound sodium phosphate? Well, for this, you have to remember that phosphate is PO43 minus. So you're going to have 3 sodiums and 1 phosphate, so Na3PO4. Next up is, what is the empirical formula for the compound shown below? Okay, we've got carbon, hydrogen, and oxygen in here. Now, one thing that's worth noting about this formula is that there's only 1 oxygen, and you can't reduce 1 down any more than 1. So whatever we add up with from this molecule, that's going to be our empirical formula. So in this case, this molecule that I've shown here, your empirical and your molecular formulas are identical. So we've got 6 carbons. Okay, so then since there are 6 carbons in that ring, answer options A and C are out. How many hydrogens? 2, 4, 6, 8, 10. So we're looking at answer option B as our best answer. All right, well, I hope that was helpful, and I hope you do well on all of your future exams. All right, well, have a good one.